So this is a capacitors question, obviously advanced level, and um, we are given information as firstly we are told that there are two capacitors, they are identical in dimensions. That means they are indirectly telling us that the area is same of the plates of the capacitors and the distance is different. In the diagram we can clearly see that, but we are told that the capacitance are C1, C and 2C. So clearly this will have capacitance as C and this will have capacitance as, this will have 2C and this will have C, because C equals epsilon naught A by D. More the distance, which is here, less the capacitance. So here we took C and here 2C. Alright. Now using this information we can comment on the distances between the plates. So here the distance, if we say D, here will be 2D because capacitance is half, so distance will be twice, and this is D, this is 2D. Now the reason this is helpful, D and 2D, is because here what they have done is they have switched the plates, maintained the distance and inserted it between these two. So this is D, and they are told they have inserted it symmetrically, which is in the center, not somewhere aligned. And this is 2D, this is D. Then this would be D by 2, this would be D by 2, even though it doesn't look like it. I will simply say just D by 2, D by 2. D by 2, D by 2, and this whole is D. Now let's get to solve. Firstly, yes, also another information is this is V, and they have asked find charge flown through the battery alright. So to get a clear look, what I did to solve this is I visualized it in this way. So firstly we'll have to assign charges here. Now as we know, potential in this whole wire would be same as this, and they are sort of in parallel, so potential difference across these two plates will be V. We know the formula, V equals Q by C, Q equals CV, and using this we can say the capacitance is 2C and the capacitance is C. Here it will be 2CV and here it will be minus 2CV charge, and here it will be plus CV, here it will be minus CV charge, and this is the charge on the capacitor in the first state. This was the second state. Alright, now this, so which means we need to find the charge on the final system. Using the distances we can find the capacitance of each system of capacitor. So there's a system of capacitor, that is, this is a system of capacitor, this is a system of capacitor, and this middle one. So they are going to have capacitance as here should be 2D, my bad, this is D between. So these three are like this. These two are the same as this one. I just splitted them into two and the charge is going to be conserved in these two with this, but for our visualization this is really important to see. in exam perspective. So I'm gonna draw it neatly right here. Hope so it's visible.